Okay. Yes, may I audible to you? Okay. So let us start our today's lecture. We are discussing about the chemistry of aldehydes and ketones. Last time we have discussed and completed this topic. So today we are going to start a new topic, that is chemistry of carboxylic acids and their derivatives. Carboxylic acids and their derivatives. So here we have to discuss about the carboxylic acid. If you see the carboxylic acid, this R, C, double bond O, O and H. This carboxylic acid here, the angle in this carbon is, it is sp2 hybridized. So the internal bond angle is 120 degree. It is 120 degree. 120 degree. Okay, and it contains COOH group. So when one of the hydrogen of alkane, is replaced by the COH, is called as a carboxylic acid. It contains functional group COH. The angle in this carbon is 120. If you see the examples of this carboxylic acid, when it contains more number of the carbon atom, then it is called as a fatty acids. And in their book they have given the number of the examples of the fatty acids with the number of carbon atom and the melting point molecular formula. So try to remember some of the examples, their structures and their names. The simple example, or if you see the classification of this carboxylic acid, what are the carboxylic acid and give their classification. So these carboxylic acids, they are classified depending upon number of COH group present. One, monocarboxylic acid, then dicarboxylic acid, and poly or tricarboxylic acid. Depending upon the number of COH group present, they are called as monocarboxylic acid. It contains one COH, so RCOOH. Example, that is the acetic acid, formic acid, right? So R, suppose if it is H, C double bond OOH, formic acid. If R is CH3, it is called as acetic acid. Similarly, if R is a benzene, then it is called as benzoic acid. So these are the example of monocarboxylic acid. Dicarboxylic acid, it contains two COH group, so COH and also COOH, dicarboxylic acid. Example, oxalic acid. Then phthalic acid, here is a benzene nucleus and there is a pi bond, and here is a COOH and also COOH, is called as a phthalic acid. Tricarboxylic acid, here there is the presence of three COH group, CH2, COOH, then there is a carbon, there is a COOH, here is a H, and further CH2, COOH. So it is your citric acid. So depending upon the number of COH group present, they are classified as a mono, di and tricarboxylic acid. We are going to learn in detail about the monocarboxylic acid. Monocarboxylic acid contains one COH group, so it is a monocarboxylic acid. So we can write down the general representation of this monocarboxylic acid. So here R COOH, we can write R is equal to CN S to N CN S to N plus 1, and you can write COOH like this one. This is your general representation. Then nomenclature. Nomenclature means how to write the name of the compound. So writing the name of the compound is also very easy. Nomenclature. How to write the name of the compound? There are two names, common name and the IUPAC name. So firstly we'll see the formula, that is R C double bond O OH, then a common name and other is the IUPAC name. IUPAC name, common name and IUPAC name. Okay. So here, example, if R is H C double bond O OH. If R is CS3 C double bond O OH. Similarly, we can increase the number of the carbon atom. So CS3 CS2 C double bond O OH. It contains 3 carbon. Similarly, 4 carbon. CS3 CS2 CS2 C double bond O OH, and go on increasing the number of the carbon atom. So here 4, then 5, then 6, like this one. We can write the number of the examples. Now in the common nomenclature, what happened? It is given by its source. First is called as a formic acid. It is called as a formic acid. Why? Because this acid is formed by the boiling of the red ant, and in the Latin word formica means a red ant, so it is called as a formic acid. Second is called as acetic acid. It is called as acetic acid. So common name depends upon its the name from which it has obtained. So it depends upon the source. Number 3, it is called as second is called as acetic acid. So it is obtained from the actum. Actum in Latin word it is called as the vinegar. So it is called as acetic acid. Third is called as a propionic acid. So it is called as a propionic acid. This was the first acid. Pro means first. This was the first acid which was discovered. That's why it is called as a propionic acid. So it contains 3 carbon. Then number 4, it is called as a butyric acid. It is called as a butyric acid. So it has a smell of a rancid butter. So it is smell of rancid butter. That's why it is called as a butyric acid. Number 5th, it is called as a valeric acid. Valeric acid. As it is obtained from the valerian, that's why it is called as a valeric acid. Similarly, we can write the other example, 6th, caproic acid. So it is obtained from the goat. That's why it is called as a caproic acid. In IUPAC name, firstly we should know the corresponding alkane. So here there are only 1 carbon, so it is called as a methane. It is called as a methane, right? So this E is replaced by OIC acid, methanoic acid. So it is called as a methanoic acid. Methane, E, E is replaced by OIC acid, methanoic acid. It contains 2 carbons, so it is ethane. So ethane, E is replaced by OIC acid. So the common name and IPS name, they are also very simple. Then it contains 3 carbons, so it is a propane, PROPANE. E is replaced by OIC acid, propaneic acid. So in this way you can write the name of the other compound. So butane, butanoic acid, BUTANEOIC acid, butanoic acid. Similarly, 5 pentane, pentanoic acid, pentanoic acid, right? So in this way you have to write down the name of the compound, right? So these are the open chain compound. If you take some branch compound, for example, suppose if I write this example, that is the CH3, then CH2, then CH and COOH, and here is a CH3, right? So you can write the numbering like this one. So alpha carbon, then beta carbon, and then gamma carbon. So at alpha there is a methyl. So alpha methyl. So it is called as alpha methyl. How many carbons are there? 1, 2, 3, 4. That is a butane, butyric acid. Butyric acid. And in IP's name, so you have to give the numbering 1, 2, 3, 4, and numbering start from carbon number 1. So here carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So at 2 there is a methyl. So 2 methyl, and it contains 4 carbon. 4 means butane. E is replaced by OIC acid, butanoic acid. So in this way, if there is a branching, in this way you can write the name of the compound. Some other example has been given in your book. I think you can write yourself. Okay. Then some aromatic compound. Here is a benzene, and there is the presence of a COOH. COOH is called as a benzoic acid. Is called as a benzoic acid. Okay. Similarly, if suppose in benzoic acid there is a substitution on benzene, COOH is a benzoic acid. Suppose Br at a para position, so it is called as a para-bromo benzoic acid. Para-bromo benzoic acid. Para-bromo benzoic acid. So in this way you can write the other example also. Other example, suppose if you are having a alicyclic acids, for example, this is your cyclopropane, and there is a COOH. So cyclopropane carboxylic acid. So cyclopropane carboxylic acid. Means you have to find out how many carbons are there, the size of ring, and then you have to put the word, that is the carboxylic acid, right? It is your carboxylic acid. Okay. Then IPS name of some of the other compound which contains other functional group. For example, here is the CS3, here is the CS2, C double bond O, and here is the CS2 and COOH. Carbon number 1, carbon number 2, carbon number 3. So 3 keto. At 3 there is a keto group. 3 keto. Here is a 3, then 4, and then 5. Pentane. 3 keto. PENTANE is replaced by OIC acid. Pentanoic acid. It is your pentanoic acid. So in this way you can write the name of the compound. Some unsaturated acid, for example, here is a CH3, then CH double bond CH, then COOH numbering. Here is a 1, 2, 3, and 4. So here 2, there is a presence of the carbon-carbon double bond, butene, BUTEN. E is replaced by OIC acid, butanoic acid, right? So 2 butene. So 2 butanoic acid. So in this way you can write the name of the compound. Okay. So again there are some salts are there. How to write the name of the salts? If you know the name of the acid, we can write the name of corresponding salt. For example, suppose if I write here HC double bond O and OH, it is called as formic acid. Formic acid is your common name, and IPS name, in IPS name you can write it as methane, METHAN, methanoic acid. It is your methanoic acid. If you convert into corresponding salt, so for example HC double bond O minus and Na plus. So here this IC acid you have to replace by ATE. IC acid you have to replace by ATE, and you have to write the name of the, that is the cation. Cation is sodium formate, and here it is your sodium methanoate, METHAN O. IC acid is replaced by ATE. Right? So in this way you can write the name of this compound, methanoate. Okay, so similarly you can write the remaining examples. So the next point is the physical property of carboxylic acid. Physical properties. In physical property, here if you see the state of this carboxylic acid, the first three members means C1 to C3, it is seen that these are the colorless and having a pungent smelling liquids. So the next example, that is a C4 to C9. So they are the oily liquids. And higher members generally from C10 onwards, so they are the colorless solid. Right? So these about the physical property, that is state. Number 2, solubility. You know, light dissolves like, polar compound dissolve into polar solvent, non-polar compound dissolve into non-polar solvent. So the carboxylic acid RC double bond O, here is O and here is the H. Here is the H, C double bond, here is O, then C double bond O and R. So this will form hydrogen bonding with water. Also it can form dimerization. So here we can write the solubility. Here it can form a bond with water, so it is soluble into the polar solvent. So that's why it dissolves into the water. It get dissolved into water, and as the number of the carbon R get increased, in that case, as the number of carbon get increased, in that case the hydrocarbon skeleton get increased. As the hydrocarbon skeleton get increased, in that case the polarity will be less and the solubility get decreased. So the solubility depends upon the number of carbon atom also. So the lower members, they are soluble into the polar solvent, and higher members, they are insoluble into the polar solvent. Polar solvent like ether, alcohol and benzene or water also. The carbonic acids, these are the weak acids. Why? Because they undergo dissociation to give corresponding H plus ion. So they undergo dissociation and there is a formation of C double bond O. Here is O minus and here is a H positive. Means on dissociation there is a formation of H positive, so it is acidic in nature. So carbonic acids, they are acidic in nature. It forms a H plus ion, and this carbonic acid also they undergo formation of a dimerization. So they are having a somewhat higher melting point and a boiling point. So if you see the property, that is a boiling point, for example, propanoic acid CH3 number 1, number 2, and carbon number 3 COOH. Here the boiling point of this compound is found to be 141 degree centigrade. The molecular weight is equal to 74, and if you take corresponding alcohol, that is CS3, CS2, CS2, and CS2 and OH, the boiling point is found to be is equal to 118, and the molecular weight is found to be 74. Both are having the same molecular weight, but if you see the boiling point of the carbonic acid is more as compared to alcohol. They may ask for 2 mark. Why the boiling point of carbonic acid is more than that of alcohol? The reason is that alcohol can form a hydrogen bonding ROH, then also ROH. It undergo polarization. Here partial negative, partial positive, partial negative, partial positive, and it can form a such type of hydrogen bonding, right? So it is a intermolecular hydrogen bonding. So between the two molecules, there is the presence of only one intermolecular hydrogen bonding. But if you take the carbonic acid, so here is R, here is a R, then C double bond O, there is O, and there is H. Similarly, there is a carbon, here is a double bond O, here is O, and here is a H, second molecule of acid. So here you see that oxygen partial negative, H partial positive, oxygen partial negative, carbon positive. Similarly, positive and negative, right? So in this way, they undergo polarization. Now, between the two molecules, there is a formation of hydrogen bonding. Also, there is a formation of hydrogen bonding. So between two molecules, there is a presence of two intermolecular hydrogen bonding. So it undergo dimerization. So to boil, you have to break the two bonds. That's why it is having the higher boiling point as compared to corresponding alcohol. So let them ask in general or in particular. You can write like this one. Then order the lower acids like formic acids and acetic acid. They are having the sharp irritating odor, while butyric acid, valeric acid, caprylic acids, they are having unpleasant odor, and higher acids, these are the having little odor because they have low volatility. So if it is a volatile, then it is having the more odor. If it is a non-volatile, then it is having the less odor. So these are some of the property. The important part is the boiling point. Now let us see the next point, that is the preparation of carboxylic acid. Preparation of carboxylic acid. So first preparation, starting from ester. We can prepare corresponding acid. So when ester RC double bond O and OR ester, when undergo hydrolysis, addition of water in the presence of acid like H2SO4, it undergo hydrolysis, addition of water, addition of H, addition of OH, and you are getting here RC double bond O, and here is a OH plus H O R dash, maybe same, maybe different. So the ester when undergo acid hydrolysis, there is a formation of corresponding acid. So starting from ester, we can prepare the acid. Similarly, it can also undergo alkaline hydrolysis in the presence of alkali. So addition of water in the presence of alkali OH. So firstly, it will give corresponding sodium salt of carboxylic acid because you are using the acid. So here RC double bond O minus and Na plus if it is a NaOH, if it is a NaOH, and further it undergo hydrolysis to give corresponding acid also. Okay. So example, just you replace R by methyl ethyl propyl or maybe by the benzene, you get the number of example. So here I am not writing the example. Okay, you have to write example yourself. Second example, starting from Grignard reagent, RMGX Grignard reagent. So when a Grignard reagent, that is RMGX, RMGX react with carbon dioxide, it react with carbon dioxide. Here is O, there is a carbon carbon double bond. So what happen? Pi bond open on the oxygen, O negative, C positive. Then the reaction takes place in the presence of a dry ether, in the presence of a dry ether, and you are having R. Here is a C double bond O, right? Here is a O minus, and there's attack of MgX, magnesium complex, and magnesium complex further undergo hydrolysis in the presence of acid. There is a formation of corresponding carboxylic acid, RC double bond OH, right, plus MgX and OH, MgX and OH. So it is called as a carbonation of Grignard reagent. Carbonation of Grignard reagent. So it is called as a carbonation of the Grignard reagent. So these are some examples. Second preparation. Then we have taken the two examples of preparation. Let us see the reactions of this carboxylic acid. Reaction, chemical reactions. Chemical reactions. So in chemical reaction, here the starting number one, Hale, Pollard, Gillespie reaction. It is called as HVZ reaction. So here, if there is a presence of alpha hydrogen atom in carboxylic acid, then it undergo halogenation. How? Suppose there is a such type of acid H, and here is a H, here is a C double bond O, OH. These are alpha carbon. So there is a presence of 3 alpha hydrogen atom. When it undergo halogenation, Cl2 in the presence of phosphorus, then the hydrogen, they are replaced by the halogen, and you are getting here H, here is also H, and here is a Cl, and here is a COOH. Means if you want to undergo halogenation at alpha carbon atom, you have to use this method. The reagent is halogen in the presence of phosphorus. Similarly, also when you treat with Cl2 in the presence of phosphorus, the second molecule undergo halogenation. Here is a Cl, and also here is a H, and here is a COOH. Similarly, if it undergo halogenation in the presence of phosphorus, then the next and last hydrogen, it get replaced, and you are having a trichloroacetaldehyde. Trichloroacetaldehyde means this reagent is useful for the halogenation at alpha carbon atom. Similarly, just you replace one of the hydrogen by this H is replaced by CS3, this H is replaced by CS3, this H also CS3 and also CS3, means only the hydrogen at alpha carbon get replaced, but remaining part remains as it is. Okay. Now next reaction is the ring substitution reaction at aromatic compound. So here we have seen aromatic electrophilic substitution reaction of a benzene. There we have seen the number of reactions. If suppose there is a benzene nucleus, and on this benzene nucleus there is a COOH. If it undergo, that is aromatic electrophilic substitution reaction that you have learned in the benzene, then the hydrogen atom metacarbon is replaced by the electrophile, so it undergo aromatic electrophilic substitution reaction at meta position, and here you are having such type of substitution pattern. Okay, similarly, example, suppose if you use the reagent KNO3 plus S2SO4, it provides electrophile NO2, it provides electrophile NO2 positive. So the hydrogen atom metacarbon is replaced by the NO2, and it undergo nitration at a meta position, and here you can get, that is a COOH and metanitro-benzoic acid. Metanitro-benzoic acid. So these are the some of the examples, reactions given by the carboxylic acid. So with acid also it have corresponding derivatives of acids. Next point, derivatives of acid RCOOH. Derivatives means when the H, here is R, C double bond O, here is O and H. If you replace either H or OH by any other atom or group, it is called as a derivative of a acid. For example, suppose if you replace H by R, you are getting corresponding, here is R, C double bond O, here is O, and it is replaced by R, means it is called as ester. It is called as a ester. Similarly, if it is replaced by, here is R, C double bond O, O, and if you replace by again C double bond O, R, is called as acid anhydride. Acid anhydride. It is called as acid anhydride. So you have replaced by H. You are getting the such type of example. Suppose if OH is replaced by the other group, then what happen? So if the OH replace R, C double bond O by a group called as halogen, it is called as acid halide. Acid halide. Similarly, if the OH is replaced R, C double bond O by NS2, it is called as amide. It is called as amide. So the derivatives of acids, they are, that is ester, then acid anhydride, acid halide, and amide. So there are the 4 example, right? So similarly, we can also write, right? So these are the 4 examples that you have learned, right? Now, then properties of this derivatives of acid, physical properties. Physical properties. If you see acid derivatives, they have the polar character due to the presence of the CO group. If whatever the derivatives that you have just seen, so here all these are having the polar character, right? They're having the polar character, means it having the CO group. So due to the presence of the CO group, the compound is found to be polar in nature. It is having the polar nature. Acid halide, anhydride, and esters, they have near about the similar boiling point as they that of your aldehydes and ketone. Aldehydes and ketone. having the similar molecular weight. For example, suppose if I take example like CH3, C double bond O and Cl, and corresponding that is ketone CH3, CH2, C double bond O and CH3. Here the molecular weight is equal to 78 and near about 72. Okay, and the boiling point, the boiling point is equal to 51, and here is a 80, right? Here look, the molecular weight is somewhat similar, but here the acid halide anhydrides, they are having the somewhat higher boiling point, because here the boiling point is right. So here if you see the experimental data they have given, that is the 51 and 80, means the ketones are having the higher boiling point as compared to acid halide. Why? Because it can form more polar nature, that's why it is having the higher boiling point. Okay, then the amides also can form a intermolecular hydrogen bonding. Here is R, here is here is R, C double bond O, N and H, right? Then H, here is a N, C double bond O and R, right? We can take R. So between these two molecules, there is a formation of a hydrogen bonding. So due to the hydrogen bonding, it is having the higher boiling point as compared to the corresponding, that is a ketone. So these amides can form a intermolecular hydrogen bonding. It can form a intermolecular hydrogen bonding. Okay. So these are about the some of the properties. Similarly, esters having the carbon 3 to 5, amides having the carbon 5 to 6, they are soluble in water, and all acid derivatives they are soluble in organic solvent. So if you see the derivatives they're having the polar nature. The lower members they are soluble in water, but higher members they are insoluble in water, right? And about the order, the carbonic acid derivatives they have somewhat some calcic order. Acid chlorides are having the pungent smell. Amides they're having irritating odor, whereas esters they're having the pleasant odor. And generally these esters they are useful in the preparation of perfumes and cosmetics. So these are some in general the physical property given by this acid halide. So here we'll see some preparation of acid halide. The next point is preparation of first derivative, that is acid halide R C double bond OX. So starting from acid, we can prepare the acid halide. How? RC double bond O OH, carboxylic acid, when treated with PCl3 or PCl5 or SOCl2, the OH is replaced by Cl, and there is a formation of a corresponding acid halide, right? Example, R is replaced by methyl or ethyl or maybe benzene. You can get the example. You can write any one of them reagent. Then this acid halide, when undergo hydrolysis, it will convert into corresponding acid. So chemical properties means it is a preparation, and next is the chemical properties. So in chemical properties, RC double bond OCl, right? So this when undergo, for example, reaction with water in the presence of, for example, acid, there is a addition of water, addition of OH, addition of H, and you are getting corresponding acid, right? Similarly, if it undergo reaction with ammonia, HNS2, similarly, addition of NS2 negative, addition of H. Why? Because the Cl is having partial negative, C is having partial positive, and you are getting RC double bond O, NH2 plus. Here is a HCl. Also, there is a formation of HCl. Similarly, the acyl halide, when you treat with benzene, when you treat with benzene in the presence of anhydrous AlCl3, then it undergo Friedel-Crafts acylation reaction, and the acyl group will attack on the benzene, and you are getting a acylation on the benzene. So here C double bond O and R, acyl benzene, you get the corresponding acyl benzene. Acyl halide, when it is treated with a reagent called as hydrogen in the presence of palladium and barium carbonate, barium carbonate. So this is one of the name reaction called as a Rosenmund reduction, Rosenmund reduction, ROSENMUND, Rosenmund reduction. It is also very important reaction. Why? Because you add H and H on this CCl bond or CX bond, and you are getting corresponding aldehyde. So by using this reaction, you can prepare aldehyde plus HCl plus HCl. So these are some of the chemical reactions given by this acid halide, right? Now the next example is acid anhydride. Acid anhydride. So let us see the preparation of acid anhydride. Next example is RC double bond O, O C double bond O, R is called as acid anhydride, anhydride preparation when two molecules of carboxylic acid, when two molecules of carboxylic acid, when react in the presence of acid, there is a removal of water, there is a removal of water, and there is a formation of corresponding acid anhydride. So you are getting RC double bond O, here is O, here is a C double bond O, and R dash may be same, may be different as it undergo dehydration. So anhydride, acid anhydride. Then here this another preparation, other preparation starting from, that is the called as, here acids when it is treated with example CS3 C double bond O, OH, when treated with AlPO4 at higher temperature, it gives a cation. Cation is a, that is a CH2 C double bond C double bond O. It is called as a cation, and this cation plus water, it again react with second molecule of acetic acid. You are getting corresponding acid anhydride, that is a CS3 C double bond O, O C double bond O, and CS3, right? It is a, there's a formation of such type of the compound. Then also from the dicarboxylic acid we can prepare anhydride. For example, next preparation, suppose CS2 C double bond O and OH, and here is a CS2 C double bond O and OH. It is a dicarboxylic acid. When you heat it, then what happen? H from this, H from this and OH from this, there is a removal of water, and there is a formation of a C double bond O, CH2 C double bond O, and here is O, means you are getting a succinic anhydride. You get the succinic anhydride, succinic anhydride. So you can get corresponding succinic anhydride, right? Similarly, if you make a ring like this one, benzene, here is a pi bond, pi bond, pi bond. Here is a C double bond O called as a benzoic acid, and again there is a COOH is called as a phthalic acid. Phthalic acid, when you heat it, it undergo, that is dehydration, removal of water takes place, and you are getting corresponding phthalic anhydride. So C double bond O, here is a C double bond O, here is O and O, that is a phthalic anhydride. So you are getting corresponding phthalic anhydride. Okay. So in this way, we can write down the preparation of this compound, the chemical reaction given by this compound. Simple chemical reactions are there. If suppose phthalic or acid anhydride chemical reactions, if acid anhydride CS3 C double bond O, here is O, here is C double bond O and CH3, if it undergo hydrolysis, addition of water, it undergo hydrolysis, then what happen? There is a attack of water, addition of OH, addition of H, and you are getting here CH3 C double bond O, OH plus HO C double bond O and CH3, means you get corresponding carboxylic acid. Similarly, if you add ammonia, ammonia is NH3. So similarly, you can add ammonia, and there is the addition of NH2, and here is a H, right? So you can get here CH3 C double bond O, NH2 amide plus CH3 C double bond O and OH, means carboxylic acid. So you are getting amide plus carboxylic acid. If suppose if you add, that is a alcohol HOCH3, so here there is O CH3 and here is a H. So what you can get? You can get here CH3 C double bond O and OCH3, means ester plus corresponding acetic acid, and suppose if this anhydride react with a benzene, it react with benzene, you know, the reaction takes place in the presence of AlCl3, it undergo Fiedler-Crafts acylation reaction, and there is a formation of corresponding acyl benzene, means here is a C double bond O and CH3. So these are the some reactions given by this acid anhydride, right? And next reaction is the reaction of, that is the esters. So esters, when it is a preparation of ester starting from carboxylic acid. If carboxylic acid RC double bond O OH react with alcohol, then it undergo dehydration, removal of water molecule, when you heat it in the presence of acid, and you are getting corresponding ester, right? One preparation. Example, just you replace R by methyl, you get the example. Second, when react with SOCl2 thionyl chloride, there is a formation of corresponding acid halide, right? and this acyl halide further, when you treat with the molecule of alcohol, then Cl from this, H from this, there is a removal of HCl. There is a removal of HCl, and there is a formation of corresponding, that is the ester. So in this way you can prepare the ester. So you have seen the preparation of ester. Let us see the chemical reactions. Chemical reactions. So we'll take the ester and then we'll stop. Okay. So esters chemical reaction in general R C double bond O O R dash. This ester, when you undergo hydrolysis, addition of water in the presence of H2SO4 acid, so there is attack of water, right? Addition of H, addition of OH, and there is a formation of RC double bond O OH plus HOR dash, means acid and alcohol. But if you carry out reaction in the presence of alkali, so acid form, it will convert into corresponding salt O minus and Na plus sodium carboxylate plus alcohol, right? The next reaction here, if you react with that is ammonia, if you react with ammonia in the, when you heat it, then what happen? Here there is addition of H and addition of NH2, right? So the addition will take place in this way. We can write the addition also like this one. Addition of water also you can write like this one. Addition of OH, just wait. Okay, thank you. So at 11 o'clock we have national anthem every day. So here there is the addition of ammonia. So here what you can do, you can add NH2 and you can add H. So what you can get, amide RC double bond O NH2 plus alcohol, right? Plus alcohol, amide plus alcohol, addition of ammonia. Further, if suppose if you add the other molecule of alcohol R dash, they are different than this one. Suppose if you take this CS3OH, then what happen? There is attack of CH3O minus and H, and you can get here RC double bond O. There is attack of OCH3 positive and negative plus HOR dash, means again you are getting the methyl carboxylate and alcohol. Next reaction, reaction with the Grignard reagent. Reaction with the Grignard reagent of ester. So R C double bond O R dash, it react with two molecules of RMGX. It is seen that there is a formation of corresponding alcohol. There is a formation of corresponding alcohol, that is a tertiary alcohol, right? Mechanism. Here, firstly, we'll add the first molecule of RMGX, right? RMGX. So what happened? pi bond open here, you are having ester, right? So what happen? These are R, C, O, here is O, R dash, M, G, X plus, here is R double dash, suppose, right? R double dash. Further, this magnesium complex, the this sigma bond will shift here and this will shift here, right? And there is removal of OAT, and you are getting corresponding, here is R, here is a C double bond O and R double dash plus second molecule of RMGX in the presence of dry ether, pi bond open on the oxygen, O negative, C positive. So you are getting corresponding magnesium complex R double dash, here is O MgX. Further it undergo and here is R double dash, right? Further it undergo hydrolysis in the presence of water, and you are getting RC, here is OH, here is R double dash, and here is also R double dash, means you are getting corresponding alcohol. Last reaction from this ester. So this ester, when undergo reduction, RC double bond O and OR dash, if it undergo reduction, then it will convert into corresponding primary alcohol. For example, suppose if you treat with lithium aluminum hydride followed by hydrolysis in the presence of acid, so it is seen that there is a formation of corresponding, that is the primary alcohol. There's a formation of corresponding primary alcohol. So in this way, we have completed the ester. Only the last point has been remain, that is the chemistry of, that is the amide. Should I continue again for the 15 minutes so that we can complete? Yes. Okay. So here we have taken the reactions up to ester, right? Only one part has been remained from this topic, the chemistry of amide, right? And there is a one name reaction, Reformansky reaction, and the Perkin reaction. So I think we should take that at 1:30. I have lecture at 1:30. So today again there is a lecture at 1:30. So we'll take that point there. Okay, in doubt? Vaishnavi Sonar, in doubt? Bhagyasri?
No, sir.
Okay.
No, sir.
So okay, then we will take the lecture at again by 1:30. Okay. Will you complete this topic today only? Okay. And tomorrow again by 10 o'clock we'll take the lecture. Okay. Then we'll stop here, and thanks to all, and you can leave the meeting. Thank you. Again we'll take lecture by 1:30. Thanks to all.